This is the first part of a two-part video series that will help students and parents with thinking with mathematical models, problem 2.2, what we call the car wash problem. The first video is the getting ready portion that students and the teacher did in class. The second video will be about the actual problem set, questions A through E. Students began by reading this introduction to set the stage for our problem. And we're talking about self-service car washes, the kind that you would pull your car into and wash by hand, not the kind that you would drive your car through. In this problem, we'll look at several different companies that offer self-service car washes. So to get ready for this problem, we looked at three different car washes. The first is called Sudzo Wash and Wax. For each of these car washes, students outlined the numbers and variables in the situation to help us write an equation. For example, in Sudzo Wash and Wax, the first number we come across is 75 cents per minute. And we identified this as the rate of change. I'll abbreviate that as ROC for rate of change, which is also known as the slope in our equation. And that is a unit rate of 75 cents for every 1 minute that you use this car wash. The next thing we noticed was that there is a variable C, and the C stands for the total charge to the customer for using that car wash. Now C would be what we call the dependent, I'm going to abbreviate, dependent variable, or the Y value in an equation. And then we see that there's also a T, which is another variable, and T would be for time, and that would be the independent variable. I'm going to abbreviate that as well. Now, putting that all together, we can come up with an equation for the cost of using Sudzo Wash and Wax, and that would be C for the charge equals 0.75 times T, or 75 cents per minute that you use this car wash. Now, before we go on with this video, viewers may want to pause the video and work through the getting ready portion of this problem before pressing play once again. Moving quickly through this getting ready portion now, if we look at Pat's Power Wash, we notice a little bit different information. This time it does have a unit rate of 49 cents per minute, and that is the rate of change or the slope in our equation, but it also has this $2 number, and that's what we refer to as the starting value or the starting cost. That in an equation is called the y-intercept. We still have the same variables, the dependent variable being the charge, because the charge depends on how long you spend using car wash, and T, the independent variable. So this equation for Pat's Power Wash is C equals 0.49 T plus 2, or $2. So in real life, that would mean that the charge is 49 cents a minute plus a $2 one-time starting cost for using Pat's Power Wash. And moving on to You Wash It, they have a different set of information. It's $10 for every car, and that's the customer's charge. But this situation wants us to come up with an equation for the profit of the You Wash It owners. So the profit P becomes our dependent variable because it depends on something, and that's T, how long a customer uses their car wash. The rate here is 60 cents per minute that a person uses the car wash. So our equation becomes P for profit equaling $10 minus 60 cents per minute, or 60 cents times T. So P equals 10 minus 0.60 T. 10 being the starting value. The company starts a profit of $10 and they lose 60 cents per minute for every minute that a customer uses their car wash. Well, I hope this video has been helpful to you working with the car wash problems and thinking with mathematical models. Feel free to email me or ask further questions at this email address. Also, remember, you might want to follow up with the next video, part 2 in the series on the car wash.